Hi guys, welcome back to Depth of ML. So today we are going to solve this question that was asked in gate 16 for EC in set 1. So this is a question from linear algebra. This is a linear algebra question. And it's very simple if you know some stuff. And this is one of the questions where they have tested multiple concepts and we'll look at them. Fine. Okay, so what is this question saying? So the question says that a matrix A has been given such that the determinant of the matrix is 100. So the det of the matrix is given to be 100 and trace of the matrix is given to be 14. Okay, and they are asking you to find the value of mod A minus B. Okay, so you can see that there are two variables in this matrix, A and B, and they're asking you what is the value of mod A minus B. So first of all, the concepts that will be needed to solve this question is first of all determinant. You should know how to calculate the determinant of a matrix. More so, how to calculate the determinant of such a large matrix, which is a 4x4 matrix, efficiently. So if you don't know how to calculate the determinant of this particular matrix efficiently, you will lose a lot of time in the exam and you might not be able to solve this question well as well. Okay. So first concept that is required to solve this question is the determinant. Other thing, and also with this you will need cofactors. The second concept that you need to know to solve this question is the relationship between trace and determinant and the eigenvalues. Okay, so if you know that what is the relationship between the eigenvalues of this particular matrix, the trace and the determinant, you will be able to do this very easily. Fine. So now let's look at the concepts. So first of all, these are the two properties relating to trace and the eigenvalues. So the trace of a matrix A is basically the sum of all the eigenvalues of this matrix. Sum of all the eigenvalues, and this is actually equal to the diagonal elements. Okay, so it doesn't matter if it's a triangular matrix or it's any other matrix. Whatever elements are on the diagonal, the sum of those elements is equal to the trace of the matrix. Okay, and the product of n eigenvalues is actually equal to the determinant of A. Okay, so the determinant of A is nothing but the product of the n eigenvalues of this particular matrix. Okay, so if you know these two properties and you know how to compute the determinant efficiently, you will be able to solve this question very easily. Okay, so let me just copy this matrix so that we can work with this. Okay, I'll take it to a new page and we'll work on that. So this is something that has been given to me. Also the things that have been given to me is determinant of A is actually equal to 100 and the trace of A is equals to 14. Fine. So we know that trace of A is actually equal to the sum of the diagonal elements, right? So I can write that trace of A is actually equal to A plus 5 plus 2 plus B, right? So this is nothing but A plus 7 plus B, right? And they have given me the trace already, so I can equate it and I will get one equation which is 7 is equals to A plus B. Okay, so this is my first equation. Let's try to find out the second equation. So I will copy this matrix yet again and we'll start finding the determinant of this. So determinant of this matrix can be computed in normal way also, but if you already know about the cofactors, then the calculating determinant of this particular matrix becomes very easy. Fine. So what I'm going to do is I'm trying to find rows or columns along which I can expand. And when I want to find such a row or column, that the expansion is easier, I will try to find a row or a column with maximum number of zeros. Okay, so I can see there are two such rows and columns. So this is one column along which I can expand, and there is another row along which I can expand. Okay, so let me choose this particular column along which I will expand. Fine. So how will I do this? So first of all, let me determine the sign of the cofactor. How to determine the sign of the cofactor? The sign of cofactor. So this fifth element, right? This fifth element, what is the index? So fifth index is I and j is equals to, so this is 1 1, this is 1 2, this is 1 3 1 4, this is 2 1, this is 2 2, right? So 2 2. So the sign of the cofactor is different by -1 to the power I plus j, right? So -1 to the power 2 plus 2, which is equals to 1, right? So my sign of cofactor will be 1. So I will write it like this, 5. Now I will hide the rows and the column where this particular value is, and I will copy whatever is left in the matrix. Okay, A 3 7. So I have eliminated this row, this column and this row. So whatever is left, I am just writing that down. Then I have 2 has been eliminated. So I have 0. I have, let me draw this again. I have 0 and 0. Then I have 2 and 0. And I have 4 and B, right? So this is the matrix, okay? So why I have chosen this particular column and not this row is that when I could see that when I'm taking that element out, the cofactor is a upper triangular matrix, and for a upper triangular matrix I know that determinant of a triangular matrix is nothing but multiplication of the diagonal elements, right? So it became very easy for me to calculate the determinant henceforth. So is equals to product of diagonal elements. Okay, so job for me became very easy. This is nothing but 5 into A into 2 into B, right? So determinant of the matrix is now coming out to be this, which is nothing but 10AB. Okay, and they had given me already, if you remember the question, they had given me the value of this particular determinant, which is 100, right? So I'll just equate it to be 100. I will write it to be equal to 100. Fine. So this is my second equation. Now let me take these two equations and solve them. So first equation I have is A plus B is equals to 7. So I'll write it down here. A plus B is equals to 7. The other equation that I found after solving the determinant is 10AB is equals to 100. Okay, so 10AB is equals to 100. Now I can replace any one from A or B. So let me replace B, which will be equal to 100 by 10. Sorry, 100 by 10A. Okay, so I can cancel this out and B is equals to 10 by A. Okay, now let me put this value in this first equation. So let's put B is equals to 10 by A in equation 1. Fine. So how will we do that? We'll write A plus B is equals to 7. A plus 10 by A is equals to 7. Then A square plus 10 is equals to 7A, which gives me A square minus 7A plus 10 is equals to 0. Now I need to find the factors of this. So we can find the factors from the formula, but I can clearly see that this is equals to 5A minus 2A plus 10 is equals to 0. So this is A minus 5. I will take out minus 2 common, A minus 5, and I have the factors A minus 2 and A minus 5 to be equal to 0, right? Now I'm getting two values for A, right? And let's see, we'll have to actually check for two values of A and see what the result we are getting. So I will take this two values of A and compute for this. So A is equals to 2 or A is equals to 5. Fine. So let me solve for both the cases and see what I'm getting for B. So B, the equation was B is equals to 10 by A, right? So okay, it's fine. So B is equals to 10 by A or B is equals to 10 by 5, right? Sorry, 10 by A here. So okay, so now I'll solve for both the cases where A is equals to 2 and A is equals to B. Fine. So B is equals to, let me assume A is equals to 2 here. So B will be 10 by 2. So B is equals to 5. And over here I can do B is equals to 10 by 5, which is giving me B is equals to 2. Right. Now let me calculate the value of A minus B over here. So it will be nothing but 2 minus 5, which is, and I have to take a mod. So I'll have to take the mod of minus 3, which is nothing but 3. Right. And let me see here. So I will do A minus B over here. So A is 5 minus 2, which is equal to 3 mod, which is equals to 3, right? So I am getting value 3, right? So the answer for this question is 3. And you can see the solution is 3. Suppose that there were two different values of A. Suppose it was 2 or 7, right? In that case, you would not have reached value 3 for both the cases. And in that case, we cannot reach a unique value for B minus A mod or A minus B mod. So we will say not. So you should basically, if it's an MCQ, you will definitely have an option cannot be determined or can't say, or there will be two values given to you in the option. So you have to take that. So just be careful that you don't you have to calculate for both the values of A and not just one, because you might end up with conflicting answers, and if they are not present in your answer, you will select something as can't say or cannot be determined. Thank you.